everyone, welcome back to another episode of SciencloPodia. So today I'll be explaining about the Punnett Square. So I've pre-drawn just this slide because I felt like it's going to take a long time to redraw this and type everything, and it's not going to be that fun to watch me trying to go through the pain of typing it on here. So what I have here is the Punnett Square and an example in P. So I'll explain this later. So you might ask yourself, what even is the Punnett Square? So it's really simple. The Punnett Square is basically just a grid that shows all the possibilities of offspring from plants, animals, humans, basically anything that reproduces, which is life. And here I have an example in peas. So I have these pea pods. This one is green and it's round. This one is yellow and it's wrinkly. So just in case you can't see this is yellow and it's wrinkly. So what's happening is that what is this? Like, you might be thinking, wow, what does G, uppercase G, lowercase g, capital R, lowercase r, lower G, lower r, what does that mean? And that's a really good question. This is called a genotype. Is that? Yeah, this is called a genotype. And let me show you what a phenotype is. So this is a genotype. It's basically the characteristics that a parent has. And here's the phenotype. That's what the parent looks like, or the offspring looks like. So it's very round. The mother, let me write it down. Mother. Wait. Oops. I write it down. The mother and the dad. So basically, the mother is round and it's green, and the dad is yellow and it's wrinkly. So basically what we have here is we have this phenotype. So okay, so you must know that GG basically means that S, like in color. And you're right if you think that way. So this capital G means it's a dominant allele, meaning that even if there's at least one capital G or one capital anything, it can be a capital A to Z, then it means that that characteristic will spread on. But if there's two recessive lowercase letters, then it's going to be the opposite of what that is. In this case, it's yellow, because there are two recessives, and in this case, this is green because there is one dominant. Same for the roundness. This is round because there's at least one dominant, and this is wrinkly because there's no dominant right over here. So let me go to the next slide. Okay, so I've left out nothing here, so I can finally start drawing. So what I'm going to draw here is I'm going to draw the sperm and the egg over here. Okay, so the sperm will be at the top. So what I just want to clarify here is that from my sources, like Khan Academy, my book about biology, they said that there's actually some distribution over here, at least in the independent distribution over here. So for the sperm, it's lowercase g to lowercase r, and then it's the same. So I'll draw that for sperm. Okay. So oops, I have all the primary colors in here, I just realized. So we have a G, R, and a G, R. GR, and so we have the GR, oops, and the GR. So now we have the GR, GR, and the GR. Okay, I'll just express them differently. Okay, so we have a green, round, and a wrinkly like that. Is it right? Yeah. Okay, so now we can start drawing our amazing Punnett Square. So what's so special about Punnett Square is that it's very useful, that like it can get really, really accurate. So once we know the phenotype of a parent, we can know the offspring. And I just want to say that this is the dependent spreading of genes. It's not, it's not the independent spreading of genes. So what we have here is GR. We know that GR and GR is GR and GR, they basically is the same as this. GGR, so you can write that as a wrinkly, wrinkly here, and a wrinkly there. Okay, so now we need to get this GR of the GR. So here's a fun trick I like to use. I'm not sure if it'll be that useful or if you'll encounter this a lot. So when you have all of this as dominant, just ignore all this. It's because the dominant genes, like even just the one dominant gene can cancel out everything, cancel out all the recessive genes. We have this dominant gene right here. So we need to draw is green. So we get a green pen out here and it's round. There you go. Now we can draw a ratio. For every 2 green round peas, this is approximation. There are 2 wrinkly yellow peas. So this for Punnett Square. I'll leave a link to my sources, and I'll maybe I'll just put a link to my sources. So I hope you enjoyed this. I hope you learned a thing or two about the Punnett Square, and always remember that never stop learning, because learning will just help everything you do. And in fact, learning is a superpower that anyone can have. More powerful than walking on water, going super quick. Learning is amazing, and learning is a special superpower that anyone can have. Anyone can have. So I hope you enjoyed this, and remember to keep on learning. Bye-bye. See you next time on SciencloPodia.